physics. So the first question is, a 50 grams super ball traveling at 25 meters per second bounces off a brick wall and rebounds at 22 meters per second. A high-speed camera records this event if the ball is in contact with the wall for 3.5 milliseconds. What is the magnitude of the average acceleration of the ball during this time interval? Note that 1 millisecond is equal to 10 to the power negative 3 seconds. Perfect. So let us go and convert. The first thing is you check first the answers. The answers which we have here, we can clearly see that our answers are all in meters per second. Meaning, I have to convert this millisecond to seconds. Now, we have been told that 1 millisecond is equal to 10 raised to the power negative 3 seconds. So, we have again 3.5 milliseconds being equal to x. We don't know what x is. We want to find the seconds. You can cross multiply. Crossing multiply meaning is going to be 1 milliseconds times x being equal to 10 to the power negative 3 then times 3.5 milliseconds, like that. So what you can do, you can divide both sides by milliseconds, the same as we are cancelling out milliseconds. So x being equal to 10 to the power negative 3 times 3.5, 10 raised to the power negative 3 times 3.5, which is 0.0035. Now, it's okay, you can put this in scientific notation. Just click on mode, or you can just shift this 1, 2, 3. So it will be 3.5 times 10 raised to the power. Since you have started from this side, it's going to be to the power negative 3, like that. At the same time, without wasting time, since we are multiplying this, it's the same thing, just saying 3.5 then times 10 to the power negative 3. Not so. Seconds. Now that we have our seconds, I can go back now and start solving. Okay? Now, we want first, physics, one thing I love about physics is when you write the data, everything is going to come. The formula which you are going to use is going to come. So if I gather my data here, let us see the information we have. So we can clearly see that we have got the mass. The mass is 50 grams, but let's convert it to kgs. So it is 50 divided by 1,000. So it's 0.05. Okay? It's 0.05 kgs. What else do we have? We can clearly see that we also have what? We have been given the speed. So they're saying a 50 grams super bet, okay, traveling at 25 meters per second. So we have the initial velocity, and one thing I want you to understand again is that the initial speed which we have is 25. Now what is the final velocity? Now the question is, when they say it bounces off a brick wall and rebounds at, so the car it was going and then it bounces back, so it had to hit on something, then it has to go back. So meaning that the velocity which was going this side is positive. The velocity for bouncing back, the way when they use the bouncing back, that final velocity is always negative. Yes. So like in this case, I have to indicate that that 22 is now negative 22. So this question, a lot of people got it wrong. So you bump into something. You are driving with a car. You bump into something. You start going back. The velocity you are using to go back, since you are going against the initial velocity, it is negative. The time we have is this one. Now, we have to find, the question is, they want us to find the acceleration. Okay? So let's go. So we have um, V. So now, if we check the data we have here, before I even write the formula, if we check the data we have here, we can clearly see that we have got the velocity, the time, and both the initial and the final velocity. Mass, I don't necessarily need mass, but if there's a formula which needs mass, it's fine, I can use it. So now, according to those three equations of the motion, which formula requires me to use the velocity, initial and the final, at the same time with the time, but not distance? It is definitely the first equation, which is the V final is equal to V initial plus AT. Plug in the values. The final velocity is negative 22. Okay? The initial velocity is 25. Acceleration we don't know, but we know the time. 3.5 times 10 to the power negative 3. Shift 25 to the other side. I'm going to have this. Negative 25 minus t, or negative 22 minus 25, being equal to 3.5 times 10 to the power negative 3 times a. If you do plus these two, what are we going to have? Negative 47 being equal to 3.5 times 10 to the power 3 a. Divide both sides by 3.5 times 10 to the power negative 3. 3.5 times 10 to the power negative 3. Therefore, acceleration will be equal to negative 47 divided by 3.5 times 10 to the power negative 3. Okay? So, what are we getting? I'm getting 13,428.571 meters per second squared. Put this, all the answers are in scientific notation. Put this answer in scientific notation. Just click on mode. Again, then you go per scientific, which is 2. So, negative 1 point, negative 1.3, negative 1.34 times 10 to the power 4 meters per second squared. Now, let's go back to the question. The question is the magnitude. When you're talking about the magnitude, you are reporting your answer in positive. You are not interested in the sign. So the magnitude is now going to be 1.34 times 10 to the power 4 meters per second squared. That is the answer. So the correct answer here was A. Now, you know the beauty part about these things, especially MCQ. If you take this one as positive, if you did not understand the question, still you are going to find the answer is going to be there. So you just need to understand what they're trying to ask. That's the simplest thing. Understand what they're trying to ask, Simple. We got question 2. Yes. Let's go to question 2. So question 2, okay, I'll use this space down here. It's saying a position time graph is saying a position time graph for a particle moving along the x-axis is shown in the figure below. Find the average velocity in the time interval t is equal to 1.5 to t is equal to 4 seconds. So here is our time interval. So this is the displacement. This is the displacement, this is time. And I want you to understand one thing. Before you even solve this, one thing should come in your mind, that when you are trying to find the velocity is basically the displacement divided by what? The x, or the time. But if you have been given the distance, time graph, you have to use what we call the change in y. So we are using the y. So this is the y-axis, this is the x-axis. Okay? So what we're going to do, we're going to see the average. I put a dot on top. That is the average. Okay? So the average has to be equal to the change in y divided by the change in x. What I'm trying to tell you here is the x is the time, the y is the displacement. Now, what are we going to do? You can choose any point. The answer will still be the same. So, if I choose, the change is, I have y2 minus y1. The t is going to be t1 minus t2. Okay? So I'll say t1 minus t2. So what are we trying to say? If I check my graph here, I definitely know that where t is equal to 4. Oh, sorry. Thank you. So is t2 minus t1. That is good observation. So what is going to guide us is t1 and t2. So this is t2 and this is t1. Are we together there? Now, so where t is equal to 4, I will come here. T is equal to 4. What is the value of y when t is equal to 4 in this line? 0. So why am I getting this? Let me just do this a bit. T is equal to 4. T is equal to 4. This line here, it was falling on what? It was falling here in this line. So this is the line I'm following. I go to y, it's 0. Meaning that my average velocity, the y2 is 0 minus. Okay? Again, I have to go to t1. T1 is 1.5. 1.5 is here. If I come here, I'll find that my 1.5 is in between here, not so. So I'll go straight until this point. So if I go here, then I come here. What do you think this point is? 7. So I'll put 7. I divide it. I know T2 already is 4. I know T1 already is 1.5. So you do this. So it will be negative 7. It will be negative 7. I divide it by 4 minus that one. 2.5. I'll put here 2. If we divide, what will be our average velocity? Are you sure? -7 divided by 2.5. Okay. So -2.8. Now, when it comes for MCQ, I have to choose the answer. There is no 2.8 here, but there is positive 2.4, positive 2 point that. So I need to find the answer. Okay, I need to find the answer which is going to be near 2.8, 2.4. Sorry, alert. I need the 2.8. Sorry. So I can clearly see that I can't get this one. This is far away. So I'm dealing with now the number which is near 2.8 is 2.4. So 2.4 over 2, the positive one and the negative one. We can clearly see that we have found negative here. So therefore I'll go with B. So that's how we find these things. Yes. Any question there? Exactly. So we move to question 3. Okay, so before we even look at the answers, so the question is a ship of mass 8.4 times 10 to the power 7 kg is approaching a harbor with a speed of 16 meters per second. By using a reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? Let me read the question again. A ship of mass this is approaching a harbor with a speed of 16.4 meters per second. By using a reverse thrust, it can maintain a constant total stopping force of 920,000 Newton. How long will it take to stop? This question is very, very, very simple question. When you're talking about stopping, something is moving, you are trying to stop it. Okay? You are trying to stop it. When it comes to stop, the final velocity will be what? 0. So I know the initial speed I've been given, it was moving with 16.4. The final is definitely 0. I have the mass being equal to 8.4. Okay? 8.4 times 10 raised to the power 7. Now, the only formula I can use, they are asking us to find how long. Do we have the distance? No, we don't have. Okay? So how can we find? Now I need to use the formula which is going to help me to find this without the distance. So among the formulas we know, which formula doesn't require us to use distance? Those three. It's the first one. So now I can write this just down here. Okay. So I know that V final minus V initial plus AT. But I don't have T. When we're talking about something was being stopped. So what is happening here is this: it was moving, it has come to stop. The only force which was acting at this point, it was the force of friction, which is the friction force. So you say the summation of forces in x direction, the only force which was acting is a friction. According to Newton's second law, mass, this will replace it by mass times acceleration. So the friction is mu. Okay, what is the friction? Okay, they have given us already, we don't have to struggle. They have given us the force already. They are saying to maintain this total stopping force. So stopping force is the friction force. So this force is the friction force. It's the one I'm going to put it here. So the mass, I know it already. I divide it by a mass. I divide by mass. So it's like I'm dividing 920,000 divided by 8.4 times 10 to the power 7. So if we get our calculator, 920,000, I divide it by 8.4 times 10 to the power 7. So I'm getting 1.1 times 10 to the power negative 2 meters per second squared. That is going to be my acceleration. So I'll put it here to create space. I'll say 1.1 times 10 raised to the power negative 2. Now that I have everything, I want to find the time. So I'll get rid of this. The final velocity is 0. But now I want you again to understand one thing. When something is coming to stop, what is the acceleration? Is it going to be positive or negative? It is decelerating to be negative. So let's not forget that. So this acceleration has to be negative because it was decelerating. So the final velocity we know that is 0. The initial we know is 16.4 plus acceleration negative 1.1 times 10 to the power negative 2. Time I don't know. Shift this to the other side, negative 16.4 being equal to negative 1.1 times 10 to the power 4 times that. Divide both sides by 1.1 times 10 to the power 2. Negative 1.1 times 10 to the power 2. You can cancel this. Therefore, t will be equal to, so negative and negative will cancel, so we'll have 16.4 divided by 1.1 exponent negative 2. So I'm getting 1490.9. So this is in seconds. Now if you check the answers, okay, so we have wait just a minute. So I have 100, I have this 0.9091 seconds. If I check here all the answers which are in seconds, this should not be the answer, this should not be the answer, meaning I should be dealing with minutes. Now I want you to know one thing. So what we're going to do, to convert seconds to minutes, you divide it by 60. So I'm going to divide everything there by 60. So this gives me what? This gives me t being equal to 24.8, of which I know that I don't have 24, but if I round it off, I'll get 25 minutes. So I can clearly say that C is the correct answer in this case. Yeah. Time moves, eh? Okay. There is no tutorial sheet for linear momentum, eh? I didn't see it. No, linear momentum, it should be after work energy and power. I didn't see it. So we are on question what? Which statement is not correct? But A is saying, which one is not correct? Acceleration can be determined from the gradient of the velocity time graph. That's very true. If you have got the velocity time graph, this is time, this is velocity. You can find the acceleration using the gradient. So the gradient, we say the change in v, the same thing we're saying change in y over change in x. So you can find the acceleration. That's how we find the acceleration actually under velocity time graph. So this is true. Acceleration is the rate of change of velocity. It's very true. Acceleration is equal to change in v divided by t. So is the change of rate of velocity. This is true. Displacement can be determined from the area under the velocity time graph. I taught you this when we were doing tutorial sheet 3 under velocity time graph, to say when you want to find the distance, you find the area. For example, if you have a shape like this, we used to do this, if you can remember very well. We used to get the area for this guy, the area for that, and the area for that, for us to find the distance. Meaning this is correct. Even if I don't read D, meaning D is true. So velocity is the rate change of distance. No. Velocity is not the rate change of distance. Okay? So this is not correct. So the answer is D, which is not correct. We can jump to question 5. The box of mass M is pressed on an incline plane. The box slides down the incline with an acceleration a. If the incline makes an angle of 30 degrees with the horizontal, find the acceleration of the box. I was solving this question without even writing the data, but let me show you something here. I'll do it from this part here. That's why I have space. When we have got an incline, so this is again an advantage, I'm explaining everything on incline. Again, what I'm explaining here is going to help us to solve another question.
Okay.
If I have got an incline, the angle is theta. Let's say we have that object. One thing we should know under incline is that there is always one force that makes the whole system to go down. That force, we call it Fg. Let's leave it there. The force that is perpendicular to the surface is the normal force. We talked about this. The force, now the normal force has to be supported by the weight force. So the weight force is also in that direction. But for us to support it, we have to make another angle here. So the theta which is here is the same as the theta which is going to be there. So this is opposite. This is adjacent. So this is mg, which is the weight force. Therefore, we can clearly see that this is mg sine theta. Because it's the opposite, then this is mg cos theta. Because it is the adjacent. Now, incline is something that is very easy. Fg is going in the same direction with the mg sine theta. Therefore, Fg is equal to mg sine theta. The normal force is in the straight line with this guy. So therefore, the normal force is also going to be given this mg cos theta. That is when we're talking about incline. Now, when I want to find the acceleration, this object is moving in this direction only. We can call it x direction. So you say the summation of all the forces in x. What force do we have in x? That the force that is in x, we don't have the friction. We only have one force. What force is that? In x direction, Fg. So I'll say the summation of forces will be equal to Fg. According to Newton's second law, we replace this by what? Ma. So I'll say Ma is equal to, what is Fg according to incline? Is mg sine theta. According to the question, they are saying that the theta is 30. But they have not given us the mass. Because they know clearly that the mass is going to cancel out. I can see that I can divide both sides by mass, then mass will go. And I'll end up having A being equal to G sine theta. So I'll say A is equal to G is 9.8 sine 30. 9.8 sine 30 is 4.9. So this is going to be the acceleration. When I go back, I should be able to find the option which is 4.9 as the answer. Let's go. Question 5. Do we have 4.9 as the answer? Yeah. So that's not hard, right? Okay. Question 5. So we go to question 6. A man cleaning a floor pulls a vacuum cleaner with a force of magnitude 50 newtons at an angle of 30 degrees with the horizontal. Calculate the work done by the force on the vacuum cleaner as the vacuum cleaner is displaced 3.0 meters to the right or to the right. Okay, let's do this to make things clear. Let me explain something on work, energy, and power. So, if you have got an object moving from this point all the way to that point, it's going to move at a certain distance. That distance we'll call it d. Okay, so you are pushing this object with the force. Okay, so the work done by this force is given by force times distance. Get me right there. Let's assume that the force is 50 newtons. It has moved a distance of 3. Therefore, the work done by the force is 50 times 3. The work done by the force is 150 newtons or 150 joules, not newtons. Are we together there? Let's change things a bit. Let us assume that we have applied this force at an angle. We are putting it. It's basically the same thing which we're talking about under Newton's laws of motion. I remember it was with you. So you are putting it at an angle theta. That is the force you are using. Okay? Let us assume that the force is 30 and the angle is 30 degrees. The angle is 25 degrees. What is the work done by the force? So now, since it has been applied at an angle, I need to get, this is going to be fx, this is going to be fy. So it's basically the same things even under Newton's laws of motion. You get the x component. So you say the work done is equal to fx times d. If we go back to vectors, when we're talking about x is cos. So work will be equal to f cos theta times d. Work will be equal to the force is 30 cos 25 degrees times 3. So the work done will be equal to 30 cos 25 times 3. So I'll get 81.7 or 6 joules. Done. What I've explained here is basically exactly as this question. Now, you have a calculator, right?
Yes.
A man cleaning a floor pulls a vacuum cleaner with a force of magnitude 50 newtons at an angle of 30 degrees with the horizontal. Calculate the work done by the force on the vacuum cleaner as the vacuum cleaner is displaced 3 meters to the right. I've given you 1 minute to solve this question, then you tell me the answer.
I found 129.9
You have
equivalent to 130.
equivalent to 130, right? Exactly. So the answer was B.
Yes.
Let us go to 7. Question 7 is saying, question 7, they got it from the throw sheet. Okay, but I'm going to explain, don't worry. A 3 kg block start from rest at the top of 30 degrees incline and slide a distance of 2 meters down the incline in 1.5 seconds. Find the magnitude of the acceleration of the block the coefficient of kinetic friction between the block and the plane, the friction force acting on the block, and the speed of the block after it has strike. So this question, let me show you this. This question is as exactly as this question. Same as this question from tutorial 5. Not this one. Let me show you. That's why I've got I've got feeling that they'll definitely get questions from tutorial sheet. This question is as exactly as, what's the difference? All the questions they have asked here, a 3 kg block, this question. So solving this question is the same as we're solving part A, B, C, D. That is this question. That's why the question they're asking us to find the acceleration, mu, friction force, and the velocity. A, B, C, D. That's how this question was. A, B, C, D. You have seen it, right?
Yes.
So let's solve. That is question 7. But I solved it from the throw sheet. But let's just solve it again. Okay, so we have it's important for us first to come up with data, and then that data is going to help us to know what we're supposed to do. So the incline, everything is the same. That's what we should know. Let's not forget that everything is the same when it comes for the incline. Nothing is going to change. Okay, so let's begin. Let's do it. So we have an incline. I'll solve it from here, then we'll just go back and put the answers. We have an incline, and this incline, the angle is 30 degrees, and the guy has got 30 degrees or 30 kgs. Can't I do it from here?
3 kg.
Oh, it's 3 kg. Okay. Let me do it from here. I have an incline. Incline doesn't have an arrow. Where are we getting these arrows, eh? So it should be straight here. So the angle is 30 degrees, and the mass is 3 kgs, and we have been told that the distance is 2 meters. So what are they trying to tell us? The distance from this point to that point is 2 meters. The time interval, 1.5 seconds. What else? Incline. Okay, so they want us to find the magnitude of the acceleration of the block. I want us to be very much careful here. Okay, so here, when finding acceleration, for the fact that they have been given the distance, okay, I have been given the distance, I'm not going to use that formula of the one we were talking about for the incline. I'm going to use direct formula. I'm going to say I've been given the distance. Okay, so I'll say I have the distance, which is 2. Now the formula which I can use to find the acceleration, which formula are we going to use? do we have the initial? It started from rest, right? That's the question. So meaning that the initial velocity is what?
Hello.
Yes. What was the last thing you heard from me?
Do you have an initial?
Yes. So the question is, it has started from rest. You can see my screen.
Yes.
It has started from rest. The initial speed is 0. I don't know the final speed. I don't need to use any formula for as long as that formula requires me to plug in the final speed. I don't need it because I don't have. I don't know it. So which formula are we going to use? Are those three formulas which you have equations of motion? There are three. So the formula which requires us to plug in final speed, leave it. The one which doesn't have final speed, let's use it. Which one is that?
The S is equal to
Exact.
m
Half a t squared. So the initial, this s is d, which is 2. The initial is 0, we don't know it. So this is going to be cancelled out. Plus half. We don't know acceleration is the one we want to find. Time is 1.5. Square it. 2. So now we have 1 over 2 is 0.5 times 1.5 I square it, which is 1.125. So 1.125 times a divided by 1.125. 1.125 a will be equal to, if I do 2, I divide it by 1.125, I'll find 1.77, which is, if 1.77, or if you want you can say 1.78 meters per second squared. That is my acceleration. What was the next question? The coefficient of kinetic friction. Okay, so how can we find the coefficient of kinetic friction? Okay, so if you want, we can first find the friction force, then we come back and find the coefficient of friction. It's the same thing. Okay, so which one do you prefer? Okay, we can do any. Now when it comes for friction, that's when I'm going to that's when we have to introduce uh, that formula now. So we are going to do this. I'm going to say this is an incline, and this guy had a mass of what? Of 3 kgs. Remember what I told you about incline. I said this incline, the normal force is here, and we have the mg pointing there. So it has to support that guy. It goes like that. It will go like that. So this is mg sine theta, and this is mg cos theta. Remember, for it to move, it was moving with g. So fg. Nothing is going to change. Now there is another force acting. It was opposing. Friction was opposing the motion. Remember that the normal force is given by mg cos theta. The fg is given by mg sine theta, like that. Let's get rid of this. Now, the next thing I have to do is, this object is moving in this direction. In this direction. How many forces do we have which are acting in x direction? Uh-huh. So which one is going to carry positive? Sorry. Okay, so the object is moving in this direction. So where the object is moving to, that is positive. Yes, so Fg minus that. And we talked of no friction force. We said friction force is mu times the normal force, right? But anyway, for now, let's leave it there. The question is, we want to find, what are we trying to find? Okay, mu. So you choose. It's either we can go ahead and find, it's a two-way thing. It will be very, yes, we can find mu, then we come back and find the friction force. But it's going to be very much easy for us to jump and find the friction force. After finding the friction force, then we come and find the coefficient of friction. That is going to be very much easy. So if we want to find first the coefficient of friction, it's going to take time actually. So what I mean is, according to Newton's second law, this will be replaced by ma. Fg is mg sine theta, we know that, minus friction force. Shift friction force to the other side, shift ma to the other side. So friction force will be m is 3 times 9.8 sine 30 minus 3 again times acceleration 1.78. We found it there. So we have 9.8 times 3, which is 29.8 times 3 is 29.4. So we have 29.4 sine 30. I'm getting 14.7 minus, then we do 3 times 1.78, which is 5.34. So if we do minus, we should be able to get 9.36, of which that one we know that 9.36 is same as 9.4 newtons. So I have got my friction force 9.4. If you want, you can leave it as 9.36. Now that I have this, I know that friction force is equal to mu times the normal force, not so. But the normal force, we want to find the mu, divide both sides by the normal force. So you have mu is equal to the normal force, the friction force is 9.4. Then the mu or the normal force is mg cos theta. So it will be 9.4 divided by 3 times 9.8 cos 30. So you do 9.8, divide it, then put in the brackets 9 times 9.8 times cos 30. So I'm getting 0.37. So now I have, allow me just to do this. I put it here. So I have acceleration being equal to 1.78, my mu being equal to 0.37, my acceleration or my friction force is either, you can say is 9 point, but since everything is in two decimal places, let's just say 9.36 newtons meters per second squared. This one does. So now we want to find the last one. The last one is the speed of the block after it has slid 2 meters. Now they want us to find the speed, so the final speed. Now that we have acceleration, we can use the first formula to find the speed, or the third one, which is this, because we have been given the initial, the distance, which is 2. So we know that the initial is 0. We want to find the final. 2, acceleration is 1.78. D is 2. So you have 2 times 2, 4. 4 times 1.78. Then I'm getting 7.12. Get the square root. V final will be 2.69. Why 2? It's 2.668, so it's 2.67. So it's 2.67 meters per second. That is the final velocity. So now these are the answers we want to go back and check. So you can write them down, and then we go there and compare with the answers. You have written them down? Okay. So let's go back. So I'll go back to my question 7. So acceleration, we found that it's 1.78, meaning that A definitely is not the answer. You have seen, right? A, no. Then we go to B. B, you know, sometimes these things like MCQ, one thing I like about MCQ is the only answer which has got 1.78 is only B, meaning that I don't even have to check other things. That is the answer. The friction we found that is 3.36, right? We round it off to 3.67, 0.37. Friction 9.37 or 9.4. Okay, so we continue from where we ended. That is, now we are going to question 8, which is saying on a planet, the gravitational force F act on the mass of 6 kg. The mass is moved by the force F, okay, a distance of 30 meters in the direction of the gravitational field. The work done by the field is 450 joules. What is the force F on the mass, and what is the acceleration free for G on the planet? Okay, so we have been given the question. So they are saying that on a planet, the gravitational force F act on the mass. So the gravitational force is F, act on the mass. We have been given the mass, which is 6 kgs. Okay, what else? And then they are saying that the mass is moved by the force F at a distance of 30 meters. So this is what we were talking about yesterday, the distance of 30 meters. So the question they are asking us is, they are saying that the work done by the field is 450 joules. So the work done is 450 joules. Now, what is the force F on the mass, and what is the acceleration of the free fall, which is g on the planet. So what they're trying to tell us is we have been given already to say the work is that, and we know that the work is force times distance. So let's plug in the values which are variable. So the work is 450, the force is the one we are trying to find, time the distance is 30. Divide both sides by 30, both sides by 30. So these will cancel, meaning that my force will be 450 divided by 30. That is 15 newtons. They're asking us to find the force. You can see the question here. They're saying, what is the force on the mass and what is the acceleration due to gravity? So acceleration due to gravity, they're asking about g. Okay? And we know that for us to do that, if we do have the force, so it will be mg. Okay? So they want us to find g. Force is 15. The mass is 60. Was this 6 or 60? The mass is 6. Divide both sides by 6, here by 6. G will be equal to 15 divided by 6. That is 2.5. So I'm going to the solution, to the options now. The force, I should get 15 newtons. The G should be 2.5. So when I find these answers, then I'll conclude that that is my option. The force being equal to 15, so it should be B. 15 and 2.5. We move to question 9. Question 9, for the test for yesterday, it was also there. So the question is, an aircraft initially stationary. I want us to get to this point. Initially stationary, meaning that the initial speed is 0. Initially stationary. So the initial speed there is 0. Okay? The question continues. Initially stationary on a runway takes off with a speed of 85 kilometers per hour. So this 85 kilometers per hour, it is the final distance or the final speed. What else have been at a distance of not more than 1.2 kilometers. So D 1.20 kilometers. It's up to you whether you want to change these things into meters per second, or you can do it direct, then you just convert the acceleration which you're going. So the question is asking us the acceleration. So we choose. Do you want us to convert first this, or we can do it the way it is, then we come and convert the acceleration later?
Let's just correct it like that.
Okay, so 85 kilometers per 1 hour. I'm going to convert. I'll start with kilometers. So this is 85. So we know that in 1 kilometer there is 1000 meters. Kilometer and kilometer will cancel. I'm done with meters. I'll go to hours. In 1 hour there is 60 minutes. But again I have to convert minutes. In 1 minute there is 60 seconds. Meaning the minute and minute will cancel. The hour and hour will cancel. Now I've remained with meters and seconds. That's what I want. I'll say 85 times 1000. The answer I find, I'm going to divide it by 60 times 60, which is 3600. That is 23.61 meters per second. Are you okay with this conversion?
Yes.
So 1.2 kilometers, we want to convert it to, so we say in 1 kilometer there is 1,000 meters. Kilometer and kilometer will go. So we have 1.20 times 1,000. That is 1,200 meters. Now that I've converted, I can clearly see from the question that there is no time, so I can't use any formula which demand me time. So among those three equations, I can use the third one, which doesn't require me to use time. So I'll say v final squared is equal to, what are we going to say here, is equal to v initial squared plus 2 ad. Now, one thing we should understand is that the initial speed is 0. So I have the final being equal to 23.1. I square it, 0 squared plus 2. Acceleration I don't know. The distance is 1,200. So it's basically the same as just dividing here. I can remove that, dividing it by 2 times 2 times let's do it step by step. If I want, I can just leave it the way it is, the square there. Then here I'll say it should be 2400 times a divided by 24 divided by 24. So a is equal to 23.61 squared. I divide it by 2400. So 0.23 meters per second squared. 0.23 meters per second squared. So if we go here, what is the answer?
B.
B. Do you remember this question?
Yes.
So I don't know how I found A, because yesterday it was there, so I found B. So
And yesterday it was on question what, Musa?
um it was on question what? Let me just check.
Question 4.
Mm-mm, not 4. It was question 1.
Oh.
So the answer was A for that one.
Mm-hmm.
Then here the answer was B.
Oh.
But last time I found A. You remember? I think I was just fast. I don't know. But the answer is B. So we go to 10. So 10 is saying, which statement is not required of a pair of forces that obeys Newton's third law of motion. So Newton's third law of motion, I want you to understand this. Let's assume that this is a wall. Now you are with a car. Now you bump into the wall. Okay? This is the car. Now you bump into the wall. So the force that you are going to use to bump into this wall is the same force that the wall is going to use to exert on the car. So if the force here it is 50 newtons, it will be the same but in opposite direction. Then it is going to be negative 50 newtons. That's what we need to understand. Now, the forces, what we need to understand is that the force that the car is going to use to bump into the wall is the force of the car. Then again, that force that the wall is going to be used to bump into the car is the force of the wall. So you can clearly see that they are going to be acting on the different object, right? The wall bumps into the car bumps into the wall. So there are two different things there. I want you to understand. So that's what we call, for every action there is equal but in opposite reaction. So the magnitude is going to be the same but in opposite direction, and they are going to be acting on the different object. So based on this information which I've given you, I believe we can choose the best answer. So first one, the forces act on opposite direction. So the question is, which statement is not required? Is not required. So a lot of them are required, but which one is not required? The forces act in opposite direction. Is that true?
Yes, it's true.
Yes, it's true. Then B, the force act on different object. Is that true?
Yes, it's true.
Yes, it's true. C, the forces act on object in contact. The forces act on objects in contact. Is that true? So if you are not sure that that is true, leave it. Let's go to D. The forces are of equal magnitude. Is that true?
Yes.
Yes. So since we have said that A, B, and D, they are correct. Even if you don't understand option C, what is the answer?
It's the same thing.
It's the same C. So the answer here is C. We move to 11. A 5 kg this one also came from the sheet. A 5 kg object placed on a frictionless horizontal table is connected with a string that passes over a pulley, and then it fastened to the hanging 9 kg object as shown in the figure. Find the acceleration of the two objects and the tension in the string. So allow me to get this. I put it here. 5 9 5 9. That's what we have on. Okay, so we have this kind of pulley. I have an object. It goes here, it comes there. So this is 5 kg, this is 9 kg. Let's denote this to be M1. Let's denote this one to be M2. There is no friction at all. When you have been given this type of pulley and there's no friction, one thing we need to understand is that the only force this system, this mass is definitely bigger than that mass, so the system will go in this direction. The only system that is going to make the only thing that is going to make the system to move in this direction, it is the weight of M1. Okay, therefore the summation of the forces is going to be equal to the weight of M1. So according to Newton's second law, we replace this with mass times acceleration. So we'll say mass 1 times acceleration being equal to, so here, before we even go there, just a minute. We have got two objects, we have got two blocks, M1 and M2. So I need to add the masses. You remember what I used to tell you last time? So I need to say M1, M2, because I've got two masses. It also it pushes M1 and also M2, then times that. Then here you just put M1 times G, because the weight force is given by M1 times G. Divide both sides by M1, M2, M1, M2. These will cancel out. A is equal to M1 is 9 times 9.8, then 9 plus 5. So acceleration will be 9 times 9.8, that is 88 0.5 divided by 14. So my acceleration being equal to 6.3. What is the tension force? Tension force, you choose which one do you want to use. You can use M1 or M2. So the easiest way is to use just M2, which is 5 kgs. The only force acting is the tension force. You say the summation of forces in x direction, you only have tension force. This is going to be replaced by M2A tension force. M2 is 5, acceleration that. So if we do times, we should be able to get 31.5. Now, you can also use M1, you end up having the same answer. But we're not going to do that because of time. So the acceleration is 6.3, the tension 31.5. Any question?
It's clear. Let's check the answer.
So acceleration 3.6 or 6.3, tension 31.5, of which we can clearly see that the answer is C. We move to 12. When a bus starts, suddenly the passenger are pushed back. So this is what we call inertia. You know, when you are driving and then at a high speed, then suddenly you apply the brake. So you go in front, you go backward, back and forth until you come back to your original position. That is what we call inertia, the tendency, the property or the tendency of the body to go back to its original position. So they are saying this is an example of Newton's first law. Inertia is an example of Newton's first laws of motion. So we say that when an object is at rest, what it means there is this. When an object is at rest, it will continue being at rest. When it's moving, continue moving until the external force is applied on it. So now when you apply the external force, you start going, you apply the brake, you go backward, in front, backward until you come back to your original position. So that is an example of Newton's first law of motion. So the correct answer is C. 13. Which of the following has the maximum inertia? Again, this is an example of the first law. Now, I want you to understand something here. Inertia is given by mass times the radius squared. So inertia depends on the mass, and at the same time it depends on how big the radius is. Okay, so the options which are there, we are going to be looking at the masses. Okay, how big is the mass, also considering the what, the radius. So inertia depends on the mass and the radius of an object. So if we come back here, which of the following has maximum inertia? A molecule. A molecule is something that is very small. You know that, right?
Yes.
Yes. So I don't think a molecule can have the maximum inertia. B, a coin. The same coin we know. Okay, so let's just do this. The options which we have here, we have inertia. Okay, I have got a molecule. A molecule is something that is very small. Let's say that is a molecule. Then that is a coin. So a coin, you can clearly see that it's just more like that. Then we also have a cricket ball. A cricket ball, that is a cricket ball. So in short, here we have to look for something which is going to have a bit heavy. What else? We also have an atom, a smallest particle of an element. Just that, an atom. So which one do you think is the best answer?
Cricket ball.
Cricket ball, because we expect this to have bigger mass. We move to question. They repeated this question. Question 14. Question 14 is as exactly as question this question which we solved yesterday. Let me show you. This question 7. So they have repeated, but here now they are only asking to find the coefficient of friction, and we found that the answer was B yesterday. B, where we said the coefficient is 0.3. You remember? The acceleration is 1.7. The coefficient is 0.368. So here they asked to find, they say, this is the same question, then they said, find the magnitude of the acceleration of the block and the coefficient. Acceleration we found 0.78. So the need of us solving this. We found 1.78. So they repeated the same question just. So the answer is C. 1.78, then the coefficient of friction is 0.368. You have seen it?
Yes.
Okay. We move to 14. So 14 is saying the distance between the two telephones poles is 50. Let me just do this. So we have got these two poles. Then we have got a string here. So the distance there is 50 meters. The distance from this point to that point. The question continues to say, when a 1 kg bed lands on the midway, meaning when the 1 kg bed it come here and land here, what happens? When it lands there, what happens now is that so the telephone between the so they are saying the telephone wire midway between the poles, the wire surges 0.2 meters, meaning it sink. So after doing that, it went a bit, so it went like this. Okay, so they are saying it went a bit of that. So even that one, so it's more like you have got pause, so it went like that. So you can clearly see that it went, now the distance they're saying from where it went, this part here, the distance from here to where it went there, it is 0.2. That's what they are saying. Let me just go back to the question. So they are saying the wire surge is 0.2. So it sink from where it started from to where it went, 0.2 meters. How much tension does the bed produce on the wire? So one thing we should understand here is that since it has landed here and we have made this thing, there is a tension force here and also the tension force here. So this tension force and that tension force is the same. Therefore, one thing we should understand is that we have to take the forces. So I have got a bed. The bed is here now. Okay? So the bed is there. So this is going to be more like the hypotenuse, which is 50. Now, oh, no, not 50. The 50 is everything. Now, on the middle of 50 is what? 25. So it's more like we have something like this, of which if I want I can flip it, which is the same as this. If I flip it, so that is 50 or 25, sorry, and this part here is 0.2. So I need first to find the theta. Why am I supposed to find the theta? Because this has created an angle, the theta. So the bed is here. This bed has got the upward force and the downward force. Okay. So one thing we have to understand that is going to be the forces in y direction is the tension force. Now the tension force I'm going to get, this is the tension force, but I have to get is 2. Now 2 FTY. I have to get the component of y component, the component of y, because this is the one which is going in y direction. Then minus the mg is going down, minus mg, the weight of the bed. So this will be replaced by 0 because it was not moving. Then this will be 2 ft sine theta minus mg. Shift mg to the other side. So it's going to be the same as you just say ft sine theta is equal to mg, like that. But I don't know the theta. Now I have got the hypotenuse here and 0.2 here. So I can find the theta using sine. I can say sine theta, the opposite is 0.2, the hypotenuse is 25. To find the theta, divide both sides by sine. So it will be sine inverse of 0.2 divided by 25. Therefore theta will be shift sine, open brackets, 0.2 divided by 25. So the answer I'm getting is 0.458 degrees. That's the angle. Now here I want to find the ft. I'll divide both sides by 2 sine theta, even here by 2 sine theta. The reason why I'm talking about 2, because we have two tension force, this guy and that guy, and they are the same. So they are asking us the tension force for both. Okay, so these will cancel. I'll remain with ft being equal to mg divided by 2 sine theta. So if we are to plug in the values,
Before we continue,
yes, yes,
mg is the weight for the bed, right?
yes, yes.
The question also said that if you know the weight of the bed.
The question said ignore the weight of the bed.
Yes, that's correct.
Okay, so in short, what we're trying to do,
Oh, if you know the weight of
or the wire, yes, not the bed. So we're ignoring the weight of the wire. That's why we're not considering it. We're just considering the weight of the bed. Yeah. So m is 1 kg times 9.8 divided by 2 sine 0.458. So ft will be equal to 1 times 9.8 is just 9.8 divided, open brackets, 2 sine 0.458, close the brackets. Well, okay, why am I getting, so it's 9.8 divided by 2 sine 0.458. So I'm getting 612.996. If I round it off this one, because this is 996, I round it off this one, it's going to be 613.0 newtons. So let's check the answer. That's question 15. 613, which is D. So D is the correct answer in this case. So we move to question 16. Question 16 is saying if a man weighs 900 Newton on earth. Okay, so this one I can do it from here just. If a man weighs 900 newtons on earth, what would he weigh on Jupiter, where the acceleration due to gravity is 25.9 meters per second? Now, I want you to understand one thing. The weight, even if someone who is going to come from Earth, going to Pluto, going to Jupiter, going to anywhere, the weight does not change. Sorry, the mass does not change. The weight is going to change due to acceleration of gravity, but the mass will not change. So here I've been given this guy, but I need to find the mass. So I'll have weight is equal to mg. I know that the weight is 9,000. The mass I don't know. The acceleration due to gravity on Earth is 9.8. So you divide both sides by 9.8. Here 9.8. Therefore the mass will be equal to 9,000 or 900 divided by 9.8. That is 91.84. That is kg. Now the same thing, now for me to find the weight, I'll say is mg. M is 91, which we have found, 0.84, times the g. Now we have been told that is 25.9. So I'm getting the answer to be equal to 200,378.57. So 2,378.57 Newton. Now this answer, we can clearly say that our answers there, they're all in kilonewton. Kilonewton is just to divide the answer you have found with 1000. So divide it by 1000. So I'm getting 2.4, 2.378. Which one is our answer? Kilonewton. It's D. So D is the correct answer. We go to question 17, which is saying, and this one we talked about it yesterday, a person standing on the horizontal floor feels two forces, the downward pull of the gravity and the upward supporting force from the floor. These two forces, so it's more like you have this. So what is happening now here is you have the normal force. Okay, they're saying you have got the downward force of gravity, which is here, the weight force. Okay, so a person standing on a horizontal floor feels two forces, the downward pull of gravity and the upward supporting force, which is the normal force. So these two forces, one thing we should understand, the reason why the object is not going to be moving in y direction is because they are going to pair. So the forces in y direction, they are going to be the same. The weight force and the normal force, they are supposed to be the same. Okay, so they'll have the same magnitude. Okay, so the moment you see something which is talking about having an equal, which one is that? We're on question what? Question 17, right?
Yes.
Yeah. Having an equal is not correct. An equal magnitude, no, they need to have the same magnitude. So this is not correct. Okay? They're supposed to have the same magnitude because they have to cancel out. Now we are dealing with B and D. Let's read B. They have got they have got equal magnitude but do not form an action. They do not form an action or reaction. So this is what I was telling you to say. They form an action and reaction because this is the question I made a mistake, right?
I think yes.
Yeah, it should be the same one. So like what is happening here is the force. What is happening here is this. The force that this broke, or when you are standing on the floor, the force that the floor is exerting on you, get me right there. The force that the surface is exerting on you, that is the normal force. The force that you yourself you are exerting on the surface, it is the weight force. So it's more like you stand, there is a force that you yourself you are doing it on the floor. Then the floor is also doing another force. So they act is they have the reaction. It's third laws of motion. For every action there is equal but in opposite reaction. So the answer should be D. Have equal magnitude and form an action reaction pair. Definitely. I don't know how I blacked out, but that's definitely the answer D. Okay. We move to 18. How many minutes have we spent here? 40. Okay, so we have question 19. An object moving with a uniform. Oh, question 18. Sorry. Question 18 is saying an object, if all of the forces acting on an object balance so that the net force is zero, then everything has to be at rest. Now, what I mean here is this: if the if all the forces acting on an object balances so that the net force is zero, then the object. So what I want you to understand there is one thing. Um, Again, this is the one you said, but okay, I don't know what was happening to me anyway, but I've seen it. So if you have got an object, this is the object. Let's assume that the normal force is 50, the weight force is 50. This force, the applied force you are applying here, is 30, and the friction force is also 30. Do you think this object is going to move in x direction or in y direction, or what is going to happen?
Won't it be just stationary?
It's going to be stationary. It's not going to move because the forces in y direction they are same. The forces in x direction they are same. Because this is pointing up, this is pointing down, meaning that it's going to be 50 minus 50, 0. 30 minus 30, 0. So if the net force is 0, the object is not going to move. The object must be at rest. So the correct answer is D. There is no debate about that one.
I see. And what about this one? None of the above will work.
None of the above will work. I think what happened was this. The time they were getting, okay, this answer is correct, but again, the issue was um where they got this question, this B was on top of this. So if this is on top, again, I think D was not part of it. So like this is not going to happen, this is not going to happen. None of the above is going to occur. That is very true again. B and C, A and B is not going to happen. But we have the best answer already. So if we didn't have B, D, the answer would have been C. Yes. Question 9. Do you know that I was thinking maybe we were going to reach at 14 or 15, then we were going to be tired. I never thought we were going to finish.
This one really moved faster like yesterday.
Yeah, yesterday it was involving.
Mm-hmm.
An object moving with a uniform acceleration has a velocity of 12 meters per second. So I have space, I'll use here. An object moving with uniform acceleration has the velocity of 12.0 centimeters per second. Before we even continue, I think it's better for us to, okay, no, let's just leave it. In positive x direction, when its coordinate is 30 centimeters
Is 3 centimeters.
or 3 centimeters. My laptop want to die. Okay.
It should wait, we're almost done.
So 12 centimeters per second. Yes. So then they are saying if its x coordinate 2 seconds later is negative 5 centimeters, what is the acceleration? What is the acceleration? So let's first try to understand the question, and then an object moving with a uniform acceleration is not changing. So they are saying an object moving with uniform acceleration, what happens? It has got 12 centimeters per second when the distance was 3 centimeters. Okay, then it changed the direction after what? It changed the direction. So they're saying if its x coordinate 3 seconds later is negative 5 centimeters, what is the acceleration? How do you understand that question?
No idea, I'm even lost. They're talking about this.
You are,
If its x coordinate 2 seconds later is negative 5 centimeters,
mhm.
so it changed direction again.
Yes, that's what they are saying.
Now, what is this?
So it's like the distance there. What is happening is the distance changed twice. So now what they're trying to tell us is that we have been given the velocity. Okay, so it was moving with uniformly this 12 centimeters per second. So they are saying that we have now at this point the distance was 3 centimeters. Then 2 seconds later it changed. The distance now was negative 5. Okay, so what they're trying to tell us here is this is the displacement we are talking about. So if I add the displacement 2 plus negative 5, what will be the answer? Oh, sorry, it's 3, right? 3 plus negative 5, what will be the answer? So it's just a matter of you have changed the direction, you are going in this way, you change the direction again, you go in that way, 5 meters. So we have now to add the displacement. Remember, the displacement is a vector quantity. So when I add the 3 plus negative 5, what am I going to get? Hmm?
It's negative 2.
Negative 2. So we are now dealing with negative 2 centimeters. So this is the distance which we have now, the displacement. So they want us to find the acceleration. We have time. The best formula we can use, we don't have the final velocity, but we have the distance. I want to find acceleration. I think the third formula can work, where we say S or D. So you say S is equal to V initial plus times T half A T squared. So D is negative 2. So we have the V initial, which we have is 12. The time is 2 plus half. Acceleration I don't know. The time is 2, but I square it. So this is going to be 24. So it's like what I'm trying to do here is 24, it goes to the other side. So it will be negative 2 minus 24. Have you seen 12 times 2? 24. So I've shifted to the other side.
Yes.
Yes. So this now is more like we are talking about half. So it's 2 squared is 4. 4 times half is 2. You have seen that, right?
Yes.
So now we have negative 26 is equal to 2a. Divide both sides by 2. Divide both sides by 2. A will be equal to negative 13 meters per, or is centimeters, not meters. Negative 13 centimeters per second squared. And do we have this answer? Yes, it's here. And we even said that it was D, right? Have even forgotten last time talked about this. Did we get this question correct?
But see, again, C also is negative 13.
No, C is positive 13.
It is written like a negative. It's a positive.
It's a positive. This is positive. This is positive.
Okay. I reduced my screen.
Mm.
Okay.
Yeah, so um yes, negative 13 centimeters per. Okay, so now we go to the last one. This is the one you were talking about, right? The last one.
Yes, where they found the thing.
Let's see. Maybe we made a mistake, but I don't know. So the question is saying a girl throws a ball vertically upward. It takes it takes a time of 3.2 seconds to return to her hand. Assume air resistance is negligible. What is the initial speed with which the ball is thrown? This is free fall motion. In fact, I can even solve this question just using here 3.2. Let's just remember 3.2. So the time it took about 3.2 seconds. So here is the ground. So the question is saying a girl throws a ball vertically upward. It takes time this to return to her hand. Assume air resistance. So we want to find the initial speed. Perfect. So what is happening is Time is 3.2 seconds. Perfect. Now this is the ground. You throw a ball from this position going up until it comes down. Okay? So the initial speed, when it reaches at the maximum height, the final velocity there is 0. That's one thing we should know. Then, the initial speed we don't know. It's the one we want to find. Have we been given anything apart from that?
No.
No. Okay. So now, the data which we have, it was going up. G is negative 9.8. The time we have been given, which is 3.2. The V final, we know is 0. We don't know the V initial. Or we don't know the V initial. It's one we want to find. Okay? So the V final, up and now, we are going to use the first formula because it's the one which doesn't, I have everything. So V final is equal to V initial plus GT. My goal is to find the V initial. The final is 0. V initial I don't know. Then plus G is negative 9.8. The T is 3.2. So I'll say 0 is equal to, I've got V initial. This is going to be minus now. So we have 9.8 times 3.2, which is 31.36. Shift 31.36 to the other side. V initial will be equal to 31.36 meters per second. This is the answer. And there is no debate about this, 31.36. So if I round it off, the answer is going to be D. And I found D.